So the whole idea is that by checking your design and checking basically your ER diagrams and entity relationship document and applying normalization, you can reduce redundancy. So if you've got duplicated attribute stored in many places, it can be identified using these normalization rules, for example. What's the problem with the redundancy? And you know it. If you've got the same attribute stored in multiple places, then when you update the value of that attribute, you have to update it in multiple places. So if you've got the customer address stored in 2 different entities, then if the customer comes and says to you, I have changed my address, you have to update it in 2 locations. And if you forget to do one, then you will have a database that will have 2 different addresses related to the same customer. So updating, deleting of an item causes problems. So if you're deleting, for example, the telephone number of the customer, and it's stored in 2 entities, you have to do 2 deletes. One in the table customer, one in another table. So updating, you have to do updating in 2 different places. That's what we don't want to do. We want to update. If you're updating, update an attribute in one place. If you're deleting it in that one place. And when we retrieve the data, it just you will have 1 copy of each data item. So imagine you try to get the customer address, and when you get the data out from 2 different tables, you get 2 different addresses. You would not know which one is the right address. But if you store it only in one place and update it in one place, you always, when you access it, you'll get 1 address for each customer. So that's the whole idea. So have a look at here. This is an example of good design and a bad design. Have a look at the top design. There's 2 tables, the staff and the branch on the top. So staff has got the staff details, branch has got the branch details, and the connection or relationship between the staff and the branch is through branch number. So branch number here is a foreign key that establishes the relationship between the table staff and table branch. In a sense, knowing a branch number, you can find the branch address. So if you want to know where John White works, in which branch, you pick up the branch number from the table staff, then you go to the table branch and check for that branch address, and you find out the address. Look at the second design that we've got here. The second design combine the branch and the staff attributes together and built 1 table. So you have 1 table called the staff branch, and in which you've got the staff details and the branch details of the branch that each staff works in. So have a look at again. John White in here. You'll see John White works in B005. Also Julie Lee, the last row in this table, works also in the branch B005. So now the address of the branch B005 is 22 Dearest Road, London. Let's say the branch is too small and we change it. We go to 24 Dearest Street, London. What will happen is here in this table, a staff branch, you have to do 2 updates. You have to update the address for B005 at 2 different places in row 1 and the last row of this table. If it happens that you've got all your staff working in that branch, you have to do, for example, 6 updates because you've got 6 staff. So do you understand what I'm saying? But whereas in the top design, the design that you've got on top here, if the address of B005 changes to another address, you just do 1 update here. And all the references from B0 to B005 is not correct. So there are 2 different ways of designing. But sometimes when you design, you don't realize what's happening in your design. You think that's a good design. Otherwise, you wouldn't do the second kind of design that you did. So the whole idea of normalization in here is to give you a set of rules that you can apply to each of your tables, to each of your relations, to each of your entities, and figure out if it is efficient, if it doesn't have any redundancies, etc. So let's move on. Okay, I've got a couple of more transparencies to go, slides to go. We talked about redundancy. We said that insertion, deletion, modifications, when you have redundant data, causes problem. For example, if you have got the same data is stored in 2 different tables, you have to do 2 deletes to delete one data item. If you have to modify that data item and it's stored in 2 different tables, you have to do 2 updates. The same thing with insertion. If you're inserting a new value, you have to insert it in both tables. So if you store the address of your customer or customers in a table customer and in a table payment, and the customer comes and says to you, I have changed my address, you have to insert 2 new values into 2 addresses that you've got. Basically, you have to update the address of that given customer in the table customer and in the table payment, for example. In the last example, if you go back to this example, if a branch address changes in the second design in the staff branch table, you have to update it twice because the same branch number appears twice in that table, B005. If we are going to close the branch B005, then in a design that you see on the top here, we have to just delete 1 row of a table in the table branch. We just delete the first row, and that's a B005, and all details are deleted. But in the table below, we have to do 2 deletions, because this B005 appears twice in here. You see that? So insertion, deletion, and modifications are the problems that you will have with redundant data. So when you're inserting, you have to insert it in multiple places. When you're deleting, you have to delete from multiple places. When you're updating the data, you have to update it in multiple places. Say it so simply, this was, I think, the last year exam question, something like this. And many people have got difficulty with this. I have no idea why, but that's what it was. Let's now go through a few definitions, simple definitions. I put these definitions purposely from your textbook, because you're reading the textbook, you're reading this chapter 14, I think it is. And I want to go through it with you rather than just telling you first normal form means this, second normal form means this, third normal form means this. So you have to understand some basics, and the basics are very important. Imagine this. Imagine you have got 2 attributes called A and B, and you have a table or an entity called R. So you have got an entity called R, letter R, and it has got 2 attributes, A and B. We say B is, and this is the definition that you have to remember, functionally dependent on A if for each value of A in this table or in this entity, there is exactly 1 value associated. That's a B. And I'll just go back here. I might have an example here. Hopefully I have. And here, there we go. So let's say you've got a table staff, and in table staff you have a staff number, a staff name, and position. That's all you have, 3 attributes. Okay? What we are saying is a staff number is the primary key. We're telling you a staff number is the primary key, and then we have got the staff name and the staff position. And the position could be manager, admin staff, cleaner, whatever. So if I give you a staff, basically, if I give you a staff number, you will be able to tell me exactly the position of that staff, correct? So what we're saying is position is dependent, functionally dependent on the staff number. That means knowing the staff number, you can determine the positions of that staff. Nothing really complicated. The definition you saw before is a bit complicated in here, but if you think of A and B as the staff number and the B to be the position in the table staff, then knowing A, I can determine B. If you tell me the staff number, I can tell you the positions of that staff. So that's why we say position can be determined by a staff number, or position is functionally dependent on a staff number. But knowing the position, if you tell me the position of a person, let's say two people work as managers, and you say manager is a position, give me the staff number, I cannot tell you because there are two people that are staff, that are manager. Does this make sense? So functional dependency means that knowing one attribute, you can from that attribute determine other attributes in that table. And what we're really saying is that knowing the primary key, if your primary key is correct, if you've chosen the correct primary key, knowing the primary key of any attribute, any entity, you can find all the attributes related to that primary key. So that's what we're saying. All right? So what we say is, let me see. We say that the primary key is the determinant. So knowing the primary key, you can determine the value of other attributes in that table. The whole idea is that the determinant or the primary keys, when you choose a primary key, should be the minimum number of attributes that can combine together, determine other attributes in that table. So if you've got only one attribute like a staff number, that's the best. So we're saying choosing the minimum number of attributes to create a primary key is the best. Can anybody guess why? Okay, I'll give you an example. Let's say you've got a table customer, right? Or table staff that you see. That's better because you've seen the table staff today. You've got a table staff, has got a staff name, position, branch number, for example. So a staff has got the staff number, position, a staff name, position, and branch number, right? So if you tell me one staff number, and the staff number is the primary key, I can tell you the name of that staff, I can tell you the position that this staff is holding, and the branch in which this person works, correct? Very easy. Imagine you don't choose a staff number as a primary key. And what you choose, let's say you choose the staff name and the staff position as the primary key. Or you choose a staff number, a staff name, and position as the primary key. Together, the primary key of a staff. So when you ask me to give you some information about any staff, I have to ask you for 3 pieces of information. The staff number, name, and position. Because that's what you say is the primary key. So if you've got a primary key that consists of multiple attributes, then each time you want to search in that table for certain row of data, you have to provide all these attributes values. Does this make sense? And that's what it says to you here, that the primary key or the determinant in a table should have the minimum number of attributes. Does this make sense? Right? Imagine when you've called and asked for some information. You call the electricity company, gas company, your phone company to ask some information. Right? Imagine you want to make some inquiries about your telephone bill. When you call, if the primary key is your phone number or your customer number or your account number, then the person will ask you, can you tell me your account number? It's on your bill. Right? If you cannot say, if you don't have the bill in front of you, the person, if you have the bill in front of you, you give the account number, and there we go. All the details comes because let's say primary key is the account number. If you don't have the account number, what does the person has to do? Has to ask you, what's your name? What's your address? What's your date of birth? To go and do a search and find possibly you or several customers that have got the same name, date of birth, or address. It's very unlikely, but it's possible. Does this make sense? That's why when we were choosing our primary key, we were very careful. So it's nothing difficult here when you read your book. What it tells you is choose your primary key carefully. Choose, if possible, only one attribute to be your primary key. So don't choose multiple attributes representing your primary key, because if you do that, every time you want to get some data, some information from that table, then you have to specify all the attributes representing your primary key. So that's what we're telling you here. So for example, here is again example from your book, and actually this lecture follows page by page from your textbook, because this chapter 14 is a bit confusing to some people. So let's say instead of choosing a staff number alone as the primary key, we have decided to choose a staff number and a staff name to be the primary key. So each time you tell me you want to know at which branch a certain staff works, you have to give me their staff number and their name. Does this make sense? Hopefully it does. But if you choose only the staff number, you just give me the staff number. One piece of data I require from you, when I search the database, the table of staff, I search in one column. In here, when you've chosen a staff number and a staff name, I have to search two columns in that table to find the row of data that you require. So the more attributes are involved in representing a primary key, the more information you have to get from the customer, the more searches you have to do in your table. That's where the problem is. So choosing the correct attribute to represent your primary key, choosing the minimum number of attributes in your primary key helps you and helps your customer. Okay. Another thing is what's called transitive dependencies, and it's here, the definitions. Imagine this. You have got A, B, and C as the three attributes of a table. Let's say you've got a relation R, entity name is called R, and the attributes are A, B, and C, three attributes of table R. So, and you have got this situation that if you know A, from A you can determine B, and from B you can determine the value of C. Okay? This is called transitive dependencies. Because to find C, you have to know B. To find B, you have to know A. If you know A, you can find the value of B, and then from B, you can find the value of C. This is called transitive dependencies. All right? And if you have got transitive dependencies in your entity, you have to remove it. And you see why. Have a look at this example. Let's say you have got table of staff, and the table of staff has got two attributes. S name or staff name and position, S name, position, salary, branch address, and branch number. Let's say this is the table. This is the second table you saw, the bad design, right? So your staff was the primary key in the table of staff, and then in this table you've got the staff name, the staff position, how much they're earning, the branch address, and the branch number in one table, right? That's the problem. Because knowing their staff number, you can find staff name, position, salary, branch address, branch number. Right? But knowing the branch number, in here also, you can find the branch address. Does this make sense what I'm saying? Hopefully it does. Huh? Let's go back to the example. Sorry, I don't know if I've got it here. Oh, there we go. Here. Okay, let's look at the second table. Table is staff branch. The staff number is the primary key. So if you want me to tell you the details of any staff, you just give me the staff number and I tell you the details. And as you see, the problem in the second table here is that it has got redundancies. Because the branch number determines the branch address. And we told you, if we store the details like this, if you want to update the branch address, you might have to do it multiple times because multiple staff work in the same branch. If you want to delete a branch, you have to do it multiple times. Right? Does this make sense? So the second table, I've shown you before that it has got problems with update, with the deletion, and with the insertion. So for example, if we open a new branch and new staff, 2 new staff goes to that new branch, so we have to store the details of that branch, which is the branch number and the branch address with the staff, those 2 staffs in 2 rows of this table. So I store the same branch address twice, not one time or twice. So if the branch address changes, I have to update it at 2 places. If I close that branch, I have to delete it at 2 places. So what we're saying here is that's what it's called transitive dependency. You have a primary key that determines all the attributes of that table, but some of the attributes in that table can also determine other attributes. For example, here it is. The staff number determines the branch number, and branch number can determine the branch address. Of course, the staff number also determines the branch address. Does this make sense? This is where the problem is with transitive dependencies. If you have transitive dependencies in your table and you can identify it, you have to remove it. What is the solution here is that you remove the attribute, here branch address, that has got transitive dependency. You create a new table with that attribute in it, and the other attribute that determines this branch address is the branch number in the new table. So if there is an attribute that's transitively dependent on the primary key, and on other attributes other than the primary key, then you remove it from your table and create a new table. So there are the 2 things that you have to know. So one is the functional dependencies. That's the A can determine B. The staff number can determine position. That means you choose the right primary key. The second thing is you choose the right attributes for the tables. So remove transitive dependency.